So this example is coming from a Pew Research poll that found that 31.4% of 18 to 34-year-olds are currently living in their parents' home. We want to create a 95% confidence interval for this, and in order to do that, we need to realize, first of all, that this is proportions, and it's proportions because I know from the homework that's 31.4% who live at home right now. So when I'm doing a proportions confidence interval, I need to list p hat, and that'll be 0.314, because once again, according to the homework problem, it was 31.4% who live at home. I also need to list my sample size, which is 10,000, and finally my z-score. Anytime I have a 95% confidence interval, I'm using a z-score of 1.96 if it's a proportion. After I do that, the second thing I need to do is my calculations. The only thing I really need to calculate is SC, and this is equal to the square root, p hat, 1 minus p hat, all over n. If you've already looked at the hypothesis testing section, make sure you realize that in confidence intervals we use p hat because we don't have an assumed value. In hypothesis testing we use p naught here because we assume that value is better than p hat. So when I plug this in here, I'll have 0.314, 1 minus 0.314, all over 10,000. Make sure you realize all of that's under the square root. You can simplify it a little bit. 0.314 times 0.686 over 10,000 if I do that subtraction. If I'm plugging this into a calculator, we can do square root, parentheses, 0.314 times 0.686 divided by 10,000. When we go ahead and finish this out then, we're going to be getting an SE of about 0.0046, which is a really small SE. It's really small because I have a large sample size, so I don't have a lot of variation between samples. Now that I've got SE, the final step is to go ahead and put my interval together. This is step 3. When I put my interval together, I'm going to take p hat, my point estimate, plus or minus z times SE. That is, I'll take 314 plus or minus 1.96 times that 0.0046. 4 decimal places because I'm dealing with proportions. When I do this, my lower value is going to be 0.3050 after I've rounded it, and my upper value will be 0.3230 once I've rounded it. Now the part we're having trouble with is not necessarily the calculations, but actually going through with the final step, which is we need to state our answer. To state this answer, we're going to say we are 95% confident that the true percent of 18 to 34-year-olds who live at home with their parents is between 30.5% and 32.3%.